Here in this session, we're going to be adding and subtracting square roots together and determining what a good strategy is for solving those types of problems. First of all, we need to know up front that the square root of x plus the square root of y is not equal to the square root of x plus y. Common couple examples may help. Let's go ahead and start with 100. We're going to say x is 100, and we're going to say that y is also 100. We're going to give them the same value here. And then we're going to stick 100 plus 100 inside, which is the same thing as 200. Well, what is the square root of 10? Well, the square root of 100 is 10. The square root of this 100 is also 10. The square root of 200 is a little over 14, 14.14. 10 plus 10 is 20. 20 is not the same thing as 14.14. So that we can see that whenever we're adding or subtracting radicals together, square roots together, we cannot combine them the same way that we can when we multiply. Remember from previous sessions, the square root of x times the square root of y does equal the square root of x times y. The square root of x divided by the square root of y does equal, the square root of x over y does equal the square root of x divided by the square root of y. But the square root of x plus the square root of y does not equal the square root of x plus y, nor does the square root of x minus the square root of y equal the square root of x minus y. So just keep that in mind as you move forward. Here's our first example down here of a problem. The square root of 12 plus the square root of 24. And what we're asked to do here is to simplify this. So I'm going to go ahead and rewrite, but there's a strategy that we need to use as we're rewriting these radicals. And that is try to factor out of each term. Here's your first monomial, the square root of 12, your first term here, your second term being the square root of 24. If possible, try to rewrite each of those terms as a multiplication of factors whereby one of the factors is a square. So let's take a look at 12. What are some factors of 12? Well, you have 2 and 6. Well, are either 2 or 6 a square? No. Another set of factors is 3 times 4. Are 3 or 4, either of those two, a square? Yes, 4 is. So let's go ahead and rewrite radical 12 as radical 4 times 3. 4 times 3 equaling 12. This expression as well as this first one, radical 12, are identical to each other. They have the same value. Now let's take a look at our second expression, the square root of 24. Well, a couple factors we have are 12 and 2, but neither of those are squares. We have 8 times 3, neither of those are squares, but we do have 6 times 4. 4 is a square. So we can rewrite the square root of 24 as the square root of 4 times 6. Now we can simplify. Remember that the square root of 4 times 3 is going to be the same thing as the square root of 4 times the square root of 3. And then what we're adding to that is going to be the square root of 4 times the square root of 6. And let's rewrite this here in another color. What is the square root of 4? Well, the square root of 4 is 2. Square root of 3 cannot simplify anymore, so we're just going to leave that alone. 2 radical 3 plus, what's the square root of 4 here? 2. Times the square root of 6. The square root of 6 cannot be simplified, so we're just going to leave that as a radical 6. So our initial problem of radical 12 plus radical 24 written in simplified form is 2 radical 3 plus 2 radical 6. Next, we're asked to simplify this problem, radical 125 minus radical 50. Once again, what we're trying to do here is to rewrite each of our numbers that are inside the radical sign, or each one of the expressions in it, as a product of at least a factor that is a square times something else. Well, taking a look here at 125, it's maybe not initially quick to find out whether or not there is a factor of 125 that is a square, but there is. If you just used your divisibility rules for 5, you see that if a number ends with a 5 or a 0, it is divisible by 5. What is 125 divided by 5? Well, it's 25. So we could actually rewrite 125 as 25 times 5. 25 times 5 equaling 125. So we've just rewritten this to something else that has the same value. Let's come to our second one here. We're going to subtract from it radical 50. Well, radical 50 also has a square in it. The square is 25 times 2. 25 times 2 being 50. So we can see here that each of our two terms here does have a square as a factor. And in both cases, the square is 25. Now let's go ahead and simplify even further. Remember, the square root of 25 times 5 is going to be the same thing as radical 25 times radical 5. And then we are going to subtract from that radical 25 times radical 2. Remember, we just simply used our principles. It says the square root of a product can be broken apart into the square root of each of the parts that are being multiplied together. Now we can solve, or even simplify to its final stage. What is radical 25? Radical 25 is 5, because 5 times 5 is 25. We now take that times radical 5. Radical 5 cannot be simplified any further. And we are going to subtract from it the square root of 25, which is also 5, times radical 2. So radical 125 minus radical 50, when simplified, is 5 radical 5 minus 5 radical 2. Okay, let's do one more here. We have radical 16x plus radical 4x. And we are asked to simplify this. And another way to pronounce this is the square root of 16x plus the square root of 4x. Radical 16x and the square root of 16x are the same thing. Just two different ways of verbalizing it. Same with radical 4x and the square root of 4x. Once again, when you're adding or subtracting radicals together, you're trying to break down what's inside the radical sign into a multiplication of factors whereby one of the factors is a square. Well, let's go ahead and take a look. 16 by itself is a square. So we could rewrite this as radical 4. We'll just leave that alone. That's going one step too far. Radical 16 times radical x plus radical 4 times radical x. So what I've done here is I've taken our radical 16x and I've just rewritten it as radical 16 times radical x. 16 is already a square, so I don't have to do anything here. Radical 4 times x, radical 4x is the same thing as radical 4 times radical x. Radical 4 is also a square, so there's nothing to do here as well. We can now just simplify by taking the square roots of those. What is the square root of 16? Well, the square root of 16 is 4. And 4 times radical x is simply 4 radical x. Then we're going to add to it the square root of 4 times the square root of x. The square root of 4 is 2. The square root of x is radical x. So what we now have is 4 radical x plus 2 radical x. And is there a way to simplify this? Sure there is. We can combine these two together. 4 radical x plus 2 radical x is the same thing as 6 radical x. Remember, when you have a monomial and you have the same base in the monomial, remember your variable is to the same term, or excuse me, to the same exponent. Well, here the x is to the exponent of a half. Here the x is to the exponent of the half. Therefore, we combine them together in this addition problem by adding the coefficients together, the coefficients being 4 and 2. So 4 radical x plus 2 radical x equals 6 radical x. This is the simplified form of radical 16x plus radical 4x. Lastly, as a quick review, when you are simplifying problems in which you're adding or subtracting square roots, try to factor out squares from each terms. And then what you should be left with at the end is that whatever you have as your simplified answer cannot be reduced or cannot be simplified any further by factoring out squares. The only squares that you have left will be 1 and minus 1, and you cannot factor those any deeper. That'll wrap up session 83.